Imagine two black holes, each over 100 times the mass of our Sun, locked in a slow, relentless spiral for hundreds of millions of years. Every orbit sends ripples through the very fabric of reality. Gravitational waves, first predicted by Einstein in 1916. But what happened next was beyond even our boldest predictions. In 2025, the LIGO Hanford Observatory captured the signal of these two giants colliding, releasing more energy in a fraction of a second than all the stars in the observable universe emit in light, combined. The aftermath was a cosmic monster, a black hole with a mass of about 225 suns. But here's the strange part. This lies in what astrophysicists call the pair-instability mass gap, a range of black hole sizes thought to be impossible. In theory, stars massive enough to make black holes this size should actually blow themselves apart in a pair-instability supernova, leaving behind no black hole at all. Yet here it is, staring us in the face. This means we might be looking at something even wilder, a hierarchical merger, where smaller black holes merge over time to form bigger and bigger ones, inside dense star clusters, or even near the hearts of galaxies. And this opens up profound questions. Could there be black hole giants thousands of times the sun's mass hiding in the shadows? Could this be a missing link to the supermassive black holes we see at the centers of galaxies? One thing's certain, this discovery doesn't just confirm Einstein's ideas about gravity, it pushes them to the edge. Somewhere out there, in the deep dark cosmos, even bigger collisions are waiting. And we now have the tools to hear them.